Any problems we have with complex fractions, we clear them out by multiplying by the LCD. So the LCD happens to always work with whatever you have in the denominator is what you need to look for the LCD. So we have an X down here, we have a 10 down there, which means your LCD is just going to be those two things multiplied together. So it's going to be 10x. So I'm going to put a 10x next to each thing on top, and the fraction on the bottom I'll put that next to as well. Okay, so on top I have 10x times 4 over x, and then I have 10x times x. On the bottom, I just have 10x, and it's going to be times this whole fraction, x squared plus 4 over 10. So next thing I want to do is to simplify each of those. So again, if you pick the right LCD, all these should cancel out. You shouldn't have any more fractions. So for this one, we have 10 times 4 is going to be a 40, but then the x's are going to cancel out, so that's all I would have there. There's two x's you're multiplying together here, so that would be 10x squared. On the bottom, the 10s would cancel out altogether, but I still have x times x squared plus 4. About the only thing we can do here is factor the top and see if I'll be left with something I can cancel out on the bottom. Okay, so on top there, I can factor out a 10, and then 40 divided by 10 would be a 4, and then 10x squared divided by 10 would just be x squared left. Notice in this case that I do have the same thing on the top and the bottom. 4 plus x squared is the same thing as x squared plus 4. So this is a case where you're able to cancel something from the top and the bottom, and you're going to be left with 10 over x, and that's going to be your answer for this one. So that case, again, it's always good to factor, because like cases like this, there might be a chance for you to cancel something out. Let's do the next one. Similar. So this one, we've got an x in the bottom and a 7. So this time the LCD is going to be 7x. We're going to put 7x next to each thing on top and the bottom. So 7x we get 13 over x. Then we have 7x, so you have an x here. Then we'll put a 7x here next to x squared minus 13 over 7. So now we just need to multiply and reduce as we go through. All right, so the first one, we're going to get the x's to cancel out, and then we just need to multiply 7 times 13, so we get 91 here, and the x's are going to cancel. Okay, 7x squared, so we have minus 7x squared. On the bottom, the 7s are going to cancel out, and we get x times x squared minus 13. I'm going to leave it in the factored form here. On top, I want to factor out a 7. And in doing so, I get 91 divided by 7 is 13 minus x squared. At the bottom, I have x times x squared minus 13. Now, this is a little bit different than the previous one. It's not exactly the same thing that I have. The previous example, I had a plus sign there, but this time I have a minus sign. So in order to be able to get one of these to cancel, what I want to do is factor out a negative from either the top one or the bottom one. Let me factor out a negative from the bottom. So I'm going to put a negative 7 here. Now what that's going to do, it's going to change both of these signs. So if I take a negative out of this, that's going to make that negative 13. If I take a negative out of this, that's going to make plus x squared. And the bottom I have x times x squared minus 13. Of course, I can rearrange the order on top to make it x squared minus 13. And I also have the x squared minus 13 on the bottom as well. And we can see now that they both cancel out since they're both the same. So your answer would be negative 7 over x. So with plus signs, you can cancel them, but with a negative sign, if the order is switched like this, you must factor out a negative in order to make them equal. So I factored out a negative from the top. That changed the signs, negative 13 plus x squared. And then essentially you get the same thing as the bottom. And so whenever you have something like that, you're always going to get a negative that's going to come out there as well.